Hello everyone, hope all of you are well. Actually, today I'm going to discuss about energy because energy plays an important role in chemistry. As you all know, because of energy, the overlapping occurs, because of energy, the ground state goes to excited state, because of energy, hybridizations occur, because of energy, molecular orbital theory occurs. Means each and everything occurs due to energy. As Albert Einstein had not said wrong, that energy can neither be created nor be destroyed. It can just transfer from one body to another body. So first of all, today I am going to discuss about the hybridization. In the hybridization, how the energy goes from ground state to excited state and how atomic orbitals overlap. As in the previous video, especially about the valence bond theory, I have said you about the atomic orbitals overlapping, sidewise, lateral wise and symmetrical on the axis wise. I hope all of you have understand that video. If you have not understand that video, then please drop your doubt into the comment box section. In the next video, I'll explain about it. So first of all, let me inform you about the energy of the orbitals. Our chapter name is chemical bonding. In this, first of all, I will tell you about the energy orbitals. If I talk about energy of the orbitals, energy of the orbitals. See here, s orbital is spherical. You know very well. 1s, 2s, 3s, 4s, 5s, 6s, 7s. All the s orbitals are spherical. This is s orbital. Similarly, here is also an s orbital. Now, this both the s orbital can do overlapping, as I had said you also. Why they will do overlapping? Now just listen. This both the s orbital have same energy. Means this is also 1s, this is also 1s. Both are having same energy. Got it? What both are having? Both are having same energy. This is the nucleus of this atom. This is the nucleus of this atom. Now what will happen? This is, just suppose this is the A atom and this is B atom. This is the electron of A atom and this is the electron of B atom. Here is one electron, here is one. So what will happen? Since this both the atoms are having same energy, so they will be nearby to each other because they are having same energy. As they are nearby to each other, you know very well that like charges repel each other and unlike charges attract each other, right? You know very well these things. If the same charges are there, they repel each other, and unlike charges are there, so they attract each other. Why I have said you about the same charges and unlike charges? Because here the nucleus of the A atom and the nucleus of the B atom, this both will repel to each other. There will be repulsion between these two atoms. And if I talk about the electrons of the A atom and electrons of the B atom, they both will also do repulsion. Why they both will do repulsion? Because you know very well, nucleus of A atom is having positive charge, nucleus of B atom is having positive charge. So this both the atom will do repulsion. If I talk about the electrons of the A atom and the electrons of the B atom, then these both atoms will do repulsion because they both are having negative charge. Now, just suppose if I talk about the nucleus of A atom and the electron of B atom, what will be here? Because this is positive charge and this is negative charge, so both will do attraction. What will they both do? Attraction. If I talk about the nucleus of B atom and electron of A atom, this is also positive charge and this is also negative charge. So what will happen? Again there will be attraction. Why attraction and why repulsion? Because already I have said you, the same charges repel each other. The same charges repel each other and dissimilar charges attract each other. So what will happen? This electron will be attracted by this nucleus and this electron will be attracted by this nucleus. So because of this attraction, the first orbital will come closer to the second orbital's nucleus. So there will be overlapping. What there will be? Overlapping. This was the nucleus Na, Eb, Ea and B. Got it? This is Na and this is Eb. This is Ea and Nb. So they both are attached with each other because of the nuclear attraction forces. Because of the nucleus. You know very well this electron is already attached with this nucleus and this electron is already attached with this nucleus. But then also they both were different atoms. They were having same energy and then also they have turned overlapping. Why they have turned overlapping? Because of the nuclear attraction forces. Nuclear attraction forces. What is this nuclear attraction force? Can anybody tell me? I'm telling you. See, what happens here, just suppose this is an atom. In this atom, this is your nucleus and here electrons are there. So this electron is attached with the nucleus because of the nuclear attraction force. If why this electron is revolving on its own axis and why they are doing the angular momentum, if this nuclear attraction force and electron fission force would not be occurred, then this electron would fall down into the nucleus according to Maxwell quantum theory. Maxwell had said, just suppose what Maxwell had said, here this is a nucleus and just suppose here is your electron, right? Now electron will revolve and the time will come because each and every body, when they are in motion, when they are in the kinetic energy, they release some energy. If they are in the motion, they radiate some energy. As they radiate energy, a time should come when there is no energy, then this electron should fall into the nucleus. But this happens not. Why these things do not happen? Because here, as already I have said you, there are two types of forces. Electron and nucleus. Nuclear attraction force and electron and electron. Means the second outside towards the orbit, that is fission force. You know, you may have heard about these forces in the physics. In the electrostatic chapter, nuclear means you can say electron fusion force and electron fission force. Means directly you can say fusion force and fission force. These things, because of the nuclear attraction force, the electron remains in the same orbit because of the constant energy. Now, after understanding the concept, if I talk about, since electron is a wave, so if I talk about this, then there will be psi A, this, there will be psi B. So two things can be here. because of the attraction psi A plus psi B, and because of the repulsion psi A minus psi B. When there will be contraction, then there is a possibility of bonding, and when there will be destruction, then there is possibility of anti-bonding. Got it? Now these things you have to remember. Why I am teaching you these all the things? Because of energy. Today I have started with energy, and this energy will give you all the informations about the hybridization. Today's our main topic is hybridization, but before understanding the concept of hybridization, I would like to inform you these all the things. If you want to take a click of this board, then you can, otherwise I'll go ahead. As you have seen about the atomic orbitals overlapping. Now, first of all, let me see you something about how to energy gives the informations of excitement. Just suppose, as you know very well, according to Aufbau's principle. Right? According to Aufbau's principle, 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, 5f, 6d, 7p. These are the atomic orbitals in the increasing energy order. Increasing energy order means 1s is less than 2s, 2s is less than 2p. Here if I talk about, see, because they both are in the same orbitals, but remember 2s is lesser than 2p. Similarly 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, 5f, 6d, 7. You know very well, S have 2 electrons, maximum 2 electrons, P have maximum 6 electrons, D have maximum 10 electrons, and F has maximum 14 electrons. It can be 0 to 2, 0 to 6, 0 to 10, and 0 to 14. Since 0 is not there, we generally consider 1 to 2. But if in the case of removing an electron, then it can be 0 also. Okay. So first of all, this is according to the Aufbau's principle. Energy increasing. How do energy increases in the orbitals? So as you have seen here, so 1s, first of all, 1 as the lesser energy of 1s. This is your 1s orbital. Second is, in the second s, there are 2 orbitals. That is 2s and 2p. 2s and 2p. So here you can see in the 1s maximum 2 electrons can be accommodated, and in 2s also maximum 2 electrons. Now here this is 1s, 2s, 2p, in this 2px, 2py, 2pz. Now you have to understand the main concept in this P orientation. How you will understand the main concept in this P orientation? Remember, the energy level is same either in the 2px or in the 2py or in the 2pz. But the directions are different. Symmetrical, lateral, sidewise. Here you can see all the concept. If you just split this energy, 2px, 2py, 2pz. If these are only about the 2p, 2p means less than or equal to 10 electrons, less than 14. So here they will split into the two parts. How many parts? Two parts. Now question is how they will split. 2px, 2py, 2pz, you know very well, they all are in the three directions. X directions, Y direction, Z direction. Now question is how they will separate. How they will separate. Now I am telling you. First of all, this 2px and 2py, it will go down. This is 2px, 2py, and this 2pz. In the molecular orbital theory, we will learn about this 2px and 2py will have pi bonding. Which bonding? Pi bonding. And this 2pz will have sigma bonding. In the molecular orbital theory, as this was the first p orientations, and in the second p orientation also, in which there will be anti-bondings. Here 2px, 2py, 2pz. Since 2 I have written, means you have to understand there is lack of electron. 2pz energy is greater than 2px and 2py. Similarly, here will also happen. Here you will see 2px and 2py. 2px, 2py. These are anti-pi bonding, and this 2pz will go, and here it will happen. This is 2pz. This is sigma anti-bonding. So what you have seen here, if I talk about the bonding electrons and anti-bonding electrons, how do energy breaks and how do energy splits? As if anybody will ask you, whose energy is greater, 2px or 2py, 2py or 2pz, then you can see here in this orientation that 2px and 2py are having same energy level, so they are at the bottom, and 2pz is having higher energy than 2px and 2py, so he is up. So as you have seen that how energy splits, this is the most important thing that you should learn, that in the second orbital you have seen there are two energies, which are the 2s and 2p. Now this 2p also have three orientation. This was 2s and this was 2p. In the 2p I have told you 2px, 2py and 2pz. So this both are having same energy and 2pz is greater than this both. So remember this word. Similarly in 3s there will be two electrons. In 3p, 3px, 3py, 3pz. Right? So this both will have same energy and 3pz will be greater. And in 3 there is 3d also. Remember dear student, 3d. So 3dxy, 3dyz, 3dzx, 3d x square y square and 3d z square. So these are the orientation. I am just showing you how this d orbitals split into the energy. This is xy, yz, zx, x square, y square and z square. These are the axes. They split into the two terms T2g and EG. How they split? T2g and EG. It also depends upon the number of ligands. When you will go in 12th standard, in that standard there will be one chapter called coordination chemistry. In that chapter you will learn about these all the things, how do energy split. So this will be xy, yz, zx, x square, y square and z square. So have you seen how the energy splits? If there is 3 electrons or 2 electrons or 1 electrons, they will be shifted here. If it is more than, then first of all the pairing will start here. 1 electron, 2 electron, 3 electron, 4 electron, 5 electron, 6, 7th electron will be here, 8th electron will be here, 9th electron will be here, 10th electron will be here. So as you have seen how this d energy or d orbitals energy split. Got it? So as you have seen about that which is greater, so 2s, 3s is less than 3p. In the 3p, 3px, 3py, both energy are equal, 3pz is greater. After 3pz, the electrons moves to 4s orbital and then it comes to 3d. So here between this 3d and 3p, there is one energy called 4s. So 4s and after then 3d. So here you can see it is 3p is less than 4s and 4s is less than 3d. So remember these things, that how do energy shift. Now I will talk about hybridizations. As I have told you about the atomic orbitals overlapping. If you have any confusion related atomic orbitals overlapping, then I am clearing your doubts of atomic orbitals overlapping. How do atomic orbitals overlap? When they get same energy level. So as we have seen here, if I talk about S is spherical, P is dumbbell. So here Px, Py and Pz. So this is symmetrical, it is on the x-axis, this is sidewise, this is lateral wise. So Px, Py, Pz. So here in this Px dumbbell, there is one positive lobe, one is negative lobe. Positive lobe, negative lobe. Positive lobe, negative lobe. So when the atomic orbitals do overlapping, just suppose this is s orbital and s orbital. This both the s orbital have done overlapping and they have formed sigma bond. What they have formed? Sigma bond. Remember this point, how this overlapping occurs. S orbital and s orbital, they both have overlapped and they have formed sigma bond. S orbital and px orbital, they both have overlapped and they have formed sigma bond. Means when they are in the symmetrical, they form sigma bond, and when they are in the sidewise, they form pi bond. When they are in the lateral wise, then also they form pi bond. So you have heard about the sigma bond, you have heard about the pi bond. So when, if anybody asks you, when sigma bond is formed, Sigma bond is formed when the two atomic orbitals are overlapped symmetrically, or they have overlapped in the same axis. Then there is a formation of sigma bond. When the overlapping occurs between the sidewise and lateral wise, then there is a formation of pi bond. Sigma bonding, pi bonding concept clear. Now let's move towards the hybridization. Now, in the Vosper theory, we have heard about the shape of the molecules, geometry of the molecules, how the geometrical means shape of the molecules occur: linear, triangular, planar, tetrahedral, pentagonal, bipyramidal, trigonal, bipyramidal, and many more things. So we have heard about the shape of the molecule. Now, if I talk about the hybridization, then the characteristics of the bond. Just suppose methane, CH4, right? In this CH4, carbon atomic number is 6, 1s2, 2s2, 2p2, right? So here s orbital will have 2 electrons, 2s will have 2 electrons, and 2p2. This is called ground electronic configuration. What is this called? Ground state or ground electronic configuration. Now, if I talk about the excited state, so 1s2, but this 2s2 will convert into 2s1, and 1 electron will shift to 2p third. Means here both the electrons were there, and the third electrons have shifted here. Now they both are in the same energy, 2s2s. Now if I talk about the hydrogen's electron, hydrogen is having 1 atomic number, electronic configuration 1s1. So this 1s1 will overlap with this orbit. There are total 4 hydrogens. Second hydrogen 1s1 will overlap with this 2p hybridization. Third hydrogen 1s1 will overlap with 2py overlapping, and fourth hydrogen 1s1 will overlap with 2pz. Means you can see the number of hybrid orbitals. Number of hybrid orbitals. As I have told you, this is the ground state and this is called excited state. Now the energy has, because they both 2s and 2p are in the same orbit, now in the excited state 2s, 1 electron has shifted to 2p. Now there are total 1s and 3p hybrid orbitals, in which all the 4 hydrogen atoms can be accommodated, and there will be a formation of sp3 hybridization. Got it? Now question is about what is hybridization. Hybridization is a process in which 2 pure atomic orbitals overlap with each other to form an impure hybrid atomic orbitals, and the process is called hybridization. So as you have seen here, just notice this, that how all the 4 electrons of hydrogen atom, all the 4 electrons of this hydrogen atoms overlap with carbon. If anybody will ask you, then remember the words, the number of hybrid orbitals. The number of hybrid orbitals is equal to the number of atomic orbitals that get hybridized. Now question is, from which electrons these hybrid orbitals will be generated? From the valence electron. From the valence electron, outermost shell electron will generate hybrid orbitals. Outermost electron will generate hybrid orbitals. So number of hybrid orbitals is equal to the number of atomic orbitals that get hybridized. The hybridized orbitals are always equivalent in energy and shape. The hybrid orbitals are more effective in forming stable bonds than the pure atomic orbitals. If anybody will tell you which one is more stable, this one or this one, then remember, you can just directly know very well. Half filled are more stable, extra stable, so 2p3. So half filled I am not talking about. I am talking about the hybridization, hybrid orbitals I am talking about. Hybrid orbitals will give greater extent of attraction. Greater extent of attraction will give greater stability. So hybrid orbitals give the forming stable bonds of these atomic orbitals. These two hybrid orbitals directed in a space in some of the preferred direction to have minimum repulsion. See here, both the electrons were repelling to each other, so there will be a minimum repulsion. As the minimum repulsion will occur, hybridization will occur, and you can see the hybrid orbitals. Right? Now we will move ahead after the hybrid. Now, which hybrid orbitals can be overlapped with each other? So here you can see from the s orbital, since ys or sp2 or sp3, because the hybridization starts from second orbit. Hybridization starts from second orbit, and in the second orbit 2s 2p is there, in the third orbit 3s 3p 3d is there, in the fourth orbit 4s 4p 4d 4f is there. Generally we have to study about the s and p hybridization. So if there will be two hybrid orbitals, one from 2s and one from 2p, then there will be a formation of sp hybridization. If there are three atomic orbitals overlapping, two from p and one from s, then you can see here sp2 hybridization. When the hybrid orbitals 1s and 3p, sp3 hybridization. 1s 3p and 1d, sp3 dehybridization. If anybody will ask you what is the structure, linear, triangular, planar, tetrahedral, trigonal bipyramidal, pentagonal bipyramidal, dsp2, square planar, sp3 d2 or d2 sp3, octahedral. So this, when these atomic orbitals overlap with each other, so this type of shape is formed and this type of hybridization is occurred. sp, sp2, sp3, sp3d and dsp2, d2 sp3, sp3 d2 hybridizations. If anybody will ask you, in the sp hybridization, how is it? Just suppose beryllium here, right? Beryllium is the central atom. Beryllium atomic number is 4, electronic configuration 1s2 2s. This is the ground state 1s2 2s. And in the excited state, I can write here 1s2, 2s1 and 2p1. Can I write? Because in the 2s and 2p are in the same orbit, same energy. So now one electron has been transferred here. So here you can see the two hybrid orbitals are there. In these hybrid orbitals, and in two atoms one electrons can be accommodated, and then there will be a formation of sp hybridization. Then there will be a formation of sp hybridization. S will be 50% and P will be 50%. If anybody will ask you about the characteristics of here sp hybridization, S is 50% characterized and P is 50% characterized in F. Now here both the chlorine atoms, one here, another here, sp2 hybridization. You must understand about the concept of hybrid orbitals, and hybrid orbitals will be generated from the valence electron. Okay, just suppose BCl3, boron tripod. Boron atomic number is 5, 1s2, 2s2, 2p1. Can you tell me this is the ground state, and what will be the excited state? 1s2, 2s1 and 2p. So how many hybrid orbitals are there? You can see here 1s and 2p hybrid orbitals are there. So in this 3 atomic orbitals, the rest 3 boron chlorine 1 electrons will be accommodated, and the 3 atomic orbitals will be fulfilled, and the hybridization will be sp2 hybridization. Now divide this 33% S character and 67% P. Similarly, if anybody will ask me in sp3, 25% S character, 75% P character. So as you have seen, just remember about the valence electron and hybrid orbitals. These two things will give you the confirmations about the hybridization, the types of hybridization, and the geometry of the molecules predictions you have to remember. When the number of atomic orbitals, remember, when the number of atomic orbitals, hybrid orbital is 2, then sp hybridization shape will be linear. When the hybrid orbital is 3, sp2 triangular planar. When the hybrid orbital is 4, sp3 hybridization, tetrahedral structure. Atomic orbitals 5, sp3d hybridization. You can say here there are 5 atomic orbitals, 5 hybrid atomic orbitals. Can you tell me what will be the structure if there will be 5 trigonal bipyramidal? What will be that? sp3d, sp3d trigonal bipyramidal. Remember, trigonal bipyramidal. Okay. Now if I talk about the 4 atomic orbitals, but one s dsp2, then there will be square planar. Again, if I talk about dsp3, okay, 1d and 3p, dsp3. Can you tell me which type of? The same will be trigonal bipyramidal. Trigonal bipyramidal. Remember the geometries. If the 6 will be there, the 2 d2 sp3 or sp3 d2. Both will be octahedral structure. Okay, so these are the types of hybridization. These are the number of hybrid orbitals. What are these? Number of hybrid orbitals. Number of hybrid orbitals. This is hybridization. Hybridization. And this is geometry or shape of the molecules. Shape or geometry. Okay? So this thing you have to learn, that how many number of atomic hybrid orbitals are there and which type of shape they are forming. Just remember this table. Hybrid orbital is nothing, hybridization is nothing. If you have remember this table, then nothing is hybridization for you, because in the valence shell electron pair repulsion theory already we have discussed about the shape of the molecule. So for the types of hybrid orbitals, you must remember this, right? Now question is, after understanding the concept of hybridization sp3, sp3, d2, d2, sp3, now molecular orbitals. What is molecular orbital theory? MOT. Have you heard the word? See, in this whole chapter, what we have understand? We have understand Lewis theory, Lewis dot structure, after then chemical bond, types of chemical bond types. What are that? Mainly ionic and covalent. Ionic, covalent, coordinate, metallic, hydrogen and van der Waals. The 6 type of chemical bonds. After that we have discussed about, after understanding the chemical bonds, bond parameters. What are the bond parameters? Can you tell me? All of you know about the bond parameters? Yes? Anyone can tell me about what are the bond parameters? Just bond length, bond angle and bond order. These 3 things you have to remember. After that we have discussed about formal charge, Fajans rule. Okay. After then valence shell electron pair repulsion theory. After then valence bond theory. After then we have one more thing here. We have Fajans rule and resonance. We have also understand about the dipole moment. We have understand about the hybridizations, and now we will discuss about molecular orbital theory, and finally we will discuss about the hydrogen bond. This is the last concept of this chapter, that is hydrogen bonding. So the things which you have learned in this chapter is written here. If any of the concept you don't know, then please drop your doubt into the comment box section. In the next video, I'll elaborate your all the doubts. As you can see here, what more things we are going to learn in this chapter. In the next video, I will discuss about how molecular orbital theories occur, what are the constructions, destructions, number of nodes, and if the number of electrons is greater than 14, and if the numbers of electrons are less than 14, then how 2pz orbitals with sigma bonding or anti-sigma bonding goes up or down. These are all the things we will discuss in the next video. Hope all of you have understand the concept. If you have any doubt related to this concept, then please drop your doubt. That's all for today. Thank you very much. Hope all of you have enjoyed this video. Don't forget to like and subscribe the channel. Share this video with your friends so they can be also benefited. Thank you very much.